Hello everyone. Today we are going to see about the transistor configuration. What is this transistor configuration? Normally a transistor is a three-terminal device. When we use a device, we will give input in one terminal and we will take the output from the other terminal. So we need only two terminals for any device, input and output. But the third terminal, what we can do with the third terminal? We have to connect it with the ground. So that concept is called a transistor configuration. If you ground the base, then it is called common base configuration. In the input side we will have emitter, output side collector. Okay. Instead, if you ground the emitter, then it is called common emitter configuration. In the same way, if you ground the collector, then it is called common collector configuration. So that is how you have created this common configuration for transistor. Okay. So in common base configuration, we should know one more thing also. What is the input and what is the output? Input terminal is emitter, output terminal is collector. For common emitter configuration, input side is base, output side is collector. For a common collector configuration, input side is base and output side is emitter. Okay. So now one more thing we know, for a proper operation of this transistor, we have to give proper bias. What kind of bias? Emitter base what bias? Emitter base forward bias, isn't it? Emitter base forward bias. So this emitter base junction. This is NPN transistor, NPN transistor. So this one is N. So I am connecting one more negative here and this one is positive. So here collector base reverse bias. So collector is here and your N. So reverse bias means N connected to the positive terminal. Okay. So this is how you have to connect the battery for this type of circuit. Let us see here common emitter configuration. For a common emitter configuration, we have to provide a base. This one is base and emitter. Think about only the emitter and collector. Emitter means what? Forward bias. Forward bias, this is N. N is connected to the negative terminal. Okay. Then collector. Collector means collector base, reverse bias. Collector is N. So automatically here positive potential. Okay. So this is how you have to connect the biasing for this common base, common emitter and also common collector configurations. Okay. So if you understand these things properly, then the next thing is input output characteristics of this transistor. We should know the input output characteristics. Then only we can identify why we need to know about the input output characteristics. Then only we can understand the operating quality of the transistor. Okay. So first we will take the common emitter configuration. We will check what is the input and output characteristics of common emitter configuration. So this is what common emitter configuration. See, I have drawn the same circuit here. Only small variation I have done. What are the small variations? One thing is I have to take this circuit and give and one ammeter and voltmeter in the input side and output side. See, in the input side I am connecting one ammeter and one voltmeter. So one ammeter and one voltmeter. So here also in output side again I have connect one ammeter and voltmeter. So ammeter means you have to connect in series and voltmeter means it should be connected in parallel, isn't it? Then we have connected one more resistance for varying this voltage inside the circuit. The same circuit, but we have connected with a variable resistor. This variable resistor is connected to vary the voltage which is provided inside this circuit. Okay. Now we have to write the parameters for each and every area here. So this one is voltage supplied in the base region, input side. What is the input side? Base for a common emitter. So I am writing this as VBB. Okay. Output side, this voltmeter, voltage source. What is that? This one is collector side. So this is VCC. Okay, we know that. Then what about this ammeter and voltmeter? When we think about this ammeter, where it is connected to the base. So this current is IB. So I am connecting a IB current. So this one here a voltmeter. Voltmeter is connected between a base and the emitter. So here it is called VBE, base and the emitter. Again this ammeter is connected with the collector. So IC. So this voltmeter is connected between collector and the emitter. So this one is VCE. We have to write like that, then only we can start our input characteristics operation. So we are going to find the input characteristics. Input characteristics means what? The characteristic, the variation between the input voltage and the input current. That is called input characteristics. What is output characteristics? The variation between output voltage and output current. That is called output characteristics. Okay, here we will first find what is the input characteristics. Input characteristics means this is your input voltage and this is your input current. So input voltage is VBE and input current is IB. Okay, in the same way output voltage and output current. What is the output voltage? See here, VCB, and output current is IC. Okay, so this is how you have to give the access for this input and output characteristics. Then what you have to do? So while doing a common emitter configuration, these 3 points you have to do. What is that? Keep output voltage constant, vary the input voltage, and plot the input current. So first you have to keep the output voltage constant, that is VCE. So this VCE, so here there is VCE, sorry. So VCE I am keeping it constant, VCE equal to some 1 volt I am keeping. Okay, for 1 volt I am keeping constant. Then what I am going to do? I am going to vary the input voltage. So I am going to vary the input voltage and going to check what happens to the input current and going to plot the input current. So if I increase this input voltage, nothing is coming. After a particular level, the input current starts to increase. So this is the input characteristics. Okay, one more value we will get. So I am putting the VCE constant value, increasing the value to 2 volt. Now I am doing the same experiment again, varying the input voltage and checking what happens to the input current. Again the current increases more than the previous one. So this is what the input characteristics of common emitter configuration. Okay, what is the output characteristics? For output characteristics we have to do these 3 things. What is that? Keep input current constant, vary the output voltage, plot the output current. That's all. So now I am keeping the input current constant. What is input current? Input current is IB. So I am keeping the IB as 1 microampere. 1 microampere. Then I am doing this experiment. What is the experiment? I am varying the output voltage and checking what happens to the output current. So what happens when I vary the output voltage? Output current slowly increases. After a particular point it becomes a constant. Okay, then what I will do? I will vary the input current to 2 microampere. Then I am doing the same operation. What happens? The input current increases more than the previous value and then it becomes constant. Likewise I will do more number of values, and after a particular point IB equal to some 40 microampere. After a 40 microampere I am doing the same experiment. The current increases, after that it becomes constant. If I increase more than this 40 microampere, I am doing this experiment, but I am getting the same output of the previous value. If I put 50 microampere also, I am getting the same output. 60 microampere I am keeping, even then I will get the same output. What this means? The circuit gets saturated. The device gets saturated. You will not get more output here. Okay. So after this region is called a saturation region. So this region above this is called a saturation region. So this is your saturation region. Okay. Then this, if you reduce this input current less than this value, then you do this experiment, you will not get any output at all. You will not get any output. Your transistor is in the off position. So this position is called a cutoff region. This is called cutoff region. So this is your cutoff region. Okay. Then the region in between this saturation and this cutoff region, in which you get the variation in the output with respect to the input, this region is called a active region. So we should know about this properly. What is that? One is cutoff region. If your IB is very less, then no output will come in the circuit. That region is called cutoff region. If you increase your IB very largely, then the same output of the previous one will come again and again. That region is called saturation region. The region in between saturation and this cutoff is called your real active region. Okay, you have to fix the transistor in this active region, then only you will get the proper output. So you have to vary this voltage, vary this side, both the sides voltage, and make the transistor to be available in the center point of this active region. So this point is called Q point. So this, if you keep the transistor in this Q point, then the output of this circuit will be proper, otherwise you will not get a proper output. Okay, this is what your common emitter configurations, input and output characteristics. Okay, so we will, if you know this circuit properly, if you understand this input and output characteristics properly, then you can easily go with common base and common collector configuration. Okay, so the small variation only we have to do. We have to change only the parameters. Instead of this parameter, you have to find what happens. See here, this emitter, common emitter circuit is converted into this type of circuit. Okay, now this common base circuit will be converted into this way of circuit. We will check what happens with that. So here we have connected a common base circuit. You know this one, this common base circuit, we have connected one ammeter in the series and voltmeter in the parallel. Here also one ammeter and voltmeter in the output side. Okay, now the same graph is given. So here also we have given the same graph. The only variation what you have to check is the parameters what you have to connect and what you have to give to each and every area of this circuit. Okay, so here we have to connect the voltage sources. What is the output side? Output side, this one is collector. So here it is VCC. Again this side it is emitter, VEE. Okay, then here this ammeter, what is the value of this ammeter? What is the parameter of this ammeter? This is connected to the emitter. Emitter means IE. Again, what about this voltmeter? Voltmeter is connected between emitter and the base. So this is VEB. What about this ammeter? This is connected with the collector, so this is IC. What about this voltmeter? This is between collector and the base, so VCB. Okay, so this is how you have to first do the parameters variation. In the same way in common collector also. Now you tell me what is this voltage source here. Voltage source is connected to emitter, so VEE. Okay, here it is connected to the base, so VBB. In the same way the ammeter value connected to the base, so IB. Here it is connected to the base and the collector, VBC. Ammeter IE. Here voltmeter, it is between emitter and the collector, VEC. So this is how you have to first finish this circuit properly. Then you have to come to this input characteristics. Now the input characteristics of this common base configuration, how you can define. Input characteristics means it is a graph between input voltage and the input current. Input voltage, what is the input voltage? VEB. Input current is IE. Then we have to do this operation. What is that? We have to keep the output voltage constant. What is output voltage here? VCB. VCB is the output voltage. So I am keeping the output voltage constant and doing the same operation. The same way output characteristics. In the output characteristics, output voltage versus output current. Output voltage, what is that? VCB. Output current is IC. Okay, now what we will do? We will keep the input current constant. What is the input current here? IE. So IE equal to some 1 microampere. Here 2 microampere, 3 microampere, like that we have to put. Okay, so if you do like this, the same operation. So this area is your cutoff region, and this one is your saturation, and this in between is your active region, isn't it? This is your active region. In the same way here also, you itself now tell me what is the axis, x-axis, input characteristics, input voltage versus input current. That is your VBC. Input current is IB. So what is the constant value you have to keep? Output voltage, that is VEC, we have to keep it constant. Then only we will find this operation. Same operating quality for as like your common emitter configuration. Again, output characteristics between output voltage and output VEC and IE. So this is what your, this is how you have to draw the common base configuration and common emitter configuration. But the information and all are same as your common emitter configuration. Here, this is the normal ideology to make you easier for drawing and understanding the common base and common collector configuration on the whole. But in reality, it will be some small variation. There will be some small variation with respect to your real graph. What is that? In this graph will be drawn in this way, and this graph in common collector will be drawn in this way. Okay, except this the same graph also you can draw, so nothing bigger wrong in drawing the same graph. If your parameters are all right, then you can get good marks. Okay, so I hope you understand the proper ideology of configuration, transistor configuration more clearly through this video. If you like this video, kindly subscribe to our channel, like and share. Thank you.
Your subscription is our motivation. Kindly subscribe our channel. Thank you.